Welcome back. Now we'll be starting with the axioms which are given before examples of exercise 6.1. Now if you are new to my channel, do like, subscribe and share to get new updates on a regular basis. So let's start with the axioms. I have written it for your convenience. Axiom 6.1 states that if a ray stands on a line, then the sum of two adjacent angles so formed is 180 degree. If the sum of two adjacent angles is 180 degree, then the non-common arms of the angle forms a line. Actually, these are converse of each other, and there is no proof of these axioms in 9th class syllabus, but I'll be explaining you with the help of diagrams. So let's start with the axiom 6.1. If a ray stands on a line, now what is a ray? A ray is a kind of line whose only one terminating point or one starting point or one ending point exists. That is known as a ray. And what's a line? Of course, a line having two endpoints is known as a line. Then the sum of two adjacent angles so formed is 180 degree. Firstly, if a ray stands on a line, consider there is a line, name it as line AB. Now a ray stands on a line. A ray is standing on this line, and consider that the ray is CD. Now it's having only one endpoint, that's why it's known as ray. Then the sum of two adjacent angles so formed. So formed means after projecting a ray on the line AB, we get two adjacent angles. Now which are those two adjacent angles? One is ACD, the other one is DCB. The sum of two adjacent angles so formed is 180 degree. Axiom 6.1 states that angle ACD plus angle DCB will be always equal to 180 degree. Now you must remember this fact that this is known as the linear pair of angles theorem as well. That is, whenever you will find two adjacent angles which are made on only one line, then their sum is always 180 degree, and this is known as linear pair axiom. Of course, it's a linear pair, as I have told you in the previous video, that the angles, these both of the angles are being formed on only single line. That is why these are making a pair which is known as linear pair. Let's move to axiom 6.2. If the sum of two adjacent angles is 180 degree. Now firstly form two adjacent angles. Now the diagram will be same, I know. We have a line AB and we have a ray CD. Why we have to form a ray? Because we have to form two adjacent angles. If the sum of two adjacent angles is 180 degree, again two angles. Now it is given that sum of two adjacent angles is 180 degree. It means ACD and DCB is equal to 180 degree. It's given. Then what will happen? The non-common arms of the angle forms a line. Which are the non-common arms? CD arm is common in both of the angles, ACD and DCB. Now which are the non-common arms? Of course the left ones. AC and CB are the non-common arms. So it's stated that the non-common arms of the angles forms a line. It means AC plus CB or ACB is a line. Therefore ACB is a line. So this is our second axiom. First axiom say that if there is a line and there are two adjacent angles being formed by a ray, then the sum of the angles is 180 degree, and it's completely converse of this. Like if the sum is 180 degree, then the non-common arms are forming a line. So this is how you can understand the axioms 6.1 and 6.2. Let's move to our first theorem, which will be used throughout the first exercise. It's 6.1 theorem. If two lines intersect each other, then the vertically opposite angles, it means VOA in short form, are equal. Okay, now we have to prove this theorem that two lines are intersecting each other and the vertically opposite angles so formed are equal. Now firstly, in order to prove a theorem, we will write proof. Of course, the things which are given should be written prior to proof. Now consider two lines. Consider a line AB which is intersecting the line CD at O. Clear? Now firstly write, let AB and CD are two lines intersecting each other at O. Clear? Now of course if these are intersecting, then there will be a formation of angles. Which angles? Vertically opposite angles. Now how many angles are here? AOC, AOD, DOB and BOC. Okay, so we have to prove that the vertically opposite angles are equal. It means AOC will be equal to DOB and AOD will be equal to BOC. Now we will prove one part and we can write that the second part can be proved similarly. So you don't have to prove both of the parts. In any kind of theorem, if you prove the one part, you can write that the second part can be proved similarly. Okay, so no need to prove all of the parts. Now the thing is, we have studied the axiom, linear pair axioms, and we have to use those axioms. Now here are two lines. Firstly, suppose line COD. What we have to prove? So firstly write to prove angle AOC is equal to angle BOD, and AOC and BOD are done. So now angle AOD is equals to angle BOC. This thing we have to prove. Okay, so now firstly consider the line COD. On line COD or CD, of course, on line CD there are two angles which are adjacent. Which are those angles? AOC and AOD. Two adjacent angles, angle AOC and angle AOD are being formed. Clear? Therefore angle AOC plus angle AOD will be equal to 180 degree. Why? Using axiom 6.1. Clear? Now AOC and AOD, the sum of these two angles is 180 degree. Now on the same line, again on CD, two other adjacent angles are also formed, that are COB and BOD. So after writing the same line, you will get angle COB plus angle angle COB plus angle BOD. BOD is also equal to 180 degree. Why? Again using axiom 6.1. Because in the axiom 6.1 we have studied that if an angle is forming the linear pair, then of course it is equal to 180 degree. Now we have considered the line CD. Now consider the line AB. I am proving both of the parts simultaneously. In the book only one part is being proved. Okay, so I am solving both of the parts simultaneously. Now we have considered CD line. Now consider the line AB. On line AB there are two angles on this side and two on that side, AOC and COB. Angle AOC plus angle COB is equals to 180 degree. Again, why? Using axiom 6.1. And what are the other two angles? Again on AB, the angles AOD and DOB. Angles AOD plus angle DOB is also equal to 180 degree. Why? Again using axiom 6.1. Now we have applied the axiom 6.1. Now you have to take only those equations in which one angle is common. For example, COB, BOD, AOD and DOB. So in these two equations, BOD angle is common. So let's take these two equations. Firstly, mark these equations, first, second, third and fourth. Now from second and fourth equation, right hand sides are equal, so left hand sides will be also equal. So this is a basic mathematical property that if left hand sides are equal, right hand sides are also equal, or vice versa. So now If 180 is equal, now COB plus BOD, angle COB plus angle BOD will be equal to angle AOD plus angle DOB. Now angle DOB and BOD, of course, one and the same thing, just difference in the writing formation. Now BOD and DOB are same on the both sides, so it's very much clear that the same angles will be cancelled out and they will leave the same remainders. What will be the remainders? AOD and COB. So these will be same, which will give us angle COB is equal to angle AOD. Now what is angle? Angle COB and AOD are vertically opposite angles. So we have proved one part. Similarly, you can take first and third equation and you can prove. Now when you will take first and third equation, AOC and AOC will be cancelled out and AOD will be equal to COB. AOD will be equal to COB, which will be the same. So that is why you either you take second or fourth equation, or you will take first and third equation, you will get the required answer. Okay, so this is how to prove that if two lines are intersecting each other, then the vertically opposite angles so formed are also equal. So we'll be using this result in throughout the exercise. So this is how you have to prove. So before leaving my channel, do like, share and subscribe to get new and fresh updates regarding your chapters, and kindly post your problems in the comment section if you have any problem in any particular sums, because I am focusing more on examples. So if you have any particular problem, don't hesitate in posting it in the comment section.